never seen anything that destructive that close up.
In 1964, Alaska was shaken by the largest U.S. earthquake ever recorded. Magnitude 9.2. Shaking went on for over 4 minutes. 143 people died. Total property loss in 2013 dollars is estimated at $2.3 billion. There were gaping fractures, massive landslides, and the destruction of water mains, gas, sewer, telephone, and electrical systems. The epicenter was in Prince William Sound, 74 miles southeast of Anchorage, yet effects were observed as far away as Texas and Louisiana. What the 1964 Great Alaska Earthquake taught scientists was as profound and far-reaching. Initially, no one understood how or why the earthquake occurred. Immediately, 3 U.S. Geological Survey scientists were sent to figure it out.
The main airport, the Anchorage International, was closed down because the control tower had collapsed and killed the operator.
And then we went out separately, mostly separately, to look at different things so we could cover 3 times as much ground.
The scientists studied the effects from the air, on land, and along shorelines. They were astonished to find that the surface was disrupted over an area larger than California, 185,000 square miles. Some areas dropped down as much as 8 feet, and others rose up by as much as 38 feet. Barnacles, once 2 feet below the ocean surface, were suddenly several feet above. Mapping this uplift and downdrop became crucial for understanding what happened. But with no faults visible at the surface to explain it, even with months of careful observation and fieldwork, the cause of the quake remained a mystery.
It was right at this time that this idea of plate tectonics, that the surface of the Earth is broken up into roughly a dozen different plates and that they move around with respect to each other. It occurred right at the time where this idea was being put forth.
One of the scientists, geologist George Plafker, considered the quake in terms of this newly forming theory of plate tectonics. He knew the theory had new crust forming at mid-ocean ridges, but there was no explanation for where this crust went.
And so the most likely one that came to mind is that the oceanic crust is being pushed underneath that part of southern Alaska at a very low angle, and there was slip on the interface between the oceanic crust and the overlying continental crust.
These 2 crusts are converging at the rate of 1.5 inches each year. Periodic slip between the crusts produces great quakes, which Plafker called megathrust earthquakes. His realization changed our understanding of these great earthquakes. Megathrust quakes are the largest known on planet Earth. They occur in areas of colliding and descending crusts, known today as subduction zones. The uplift and downdrop of large areas from these quakes is a result of the crust being compressed over years of the plates converging. It releases like a spring, which is the earthquake. Seaward areas are uplifted, while landward areas drop down. George Plafker identified this pattern common to megathrust quakes in subduction zones.
The 1964 earthquake was the first megathrust subduction zone earthquake properly interpreted as such. As a result of that, essentially every other large subduction zone earthquake around the world sort of falls in the shadow of what we learned from the 1964 earthquake.
Next, the question became, how often do these quakes happen?
One of the obvious things that everybody wants to know when you have an earthquake like this is how frequently do they occur? Could you have one tomorrow, or is it thousands of years?
Plafker and his team drilled 50 feet into the earth and collected core samples to find out. They used carbon dating to identify when past megathrust earthquakes have occurred in south-central Alaska.
It's just an example of what has happened in the past, and the analog for that is what happened in the 1964 earthquake, namely an abrupt uplift of a broad area of mud flats that are intertidal, and then sudden appearance of freshwater plants growing on that surface.
In the cores, where the remains of land plants overlie ocean sediments, this marks a moment of sudden change. a past megathrust quake. Dating the plant remains provides an age for that quake. The team discovered 9 megathrust earthquakes have occurred in south central Alaska over the past 5,500 years. The average time span between these quakes was 630 years. Another devastating effect of the 1964 Great Alaska Earthquake was a series of deadly tsunamis. The largest, triggered by the shifting of plates when the quake began, traveled across the Pacific, wreaking havoc in coastal Oregon, California, Hawaii, and beyond. Locally, a number of extremely dangerous tsunamis occurred in south central Alaska fjords like Whittier and Valdez. Most deaths resulting from the 1964 quake came from these local tsunamis in fjords. The scientists recognized that these were produced by underwater landslides that occurred as the quake began.
In the 1964 earthquake, of the people who died, most people were killed by tsunamis. And there's kind of two ways you can make tsunamis, but the way that the tsunamis were made right here in Whittier was by underwater landslides. There's material at the edges of these fjords here, and then it's shaken in the earthquake and it slides downward into the deep part of the fjord. That generates tsunami waves, which then hit the shoreline. And the thing that's really notable about those kind of tsunamis is that they hit the shoreline very soon after the beginning of shaking. And so here in Whittier, the first tsunami wave was really well observed out in the middle of the fjord, but within 3 minutes there were 3 waves that covered a large part of Whittier. And it killed about 12 people. There was a lumber mill located about where that hotel is in the background there. There were 13 deaths in Whittier and 12 of them were over there.
Chenega, a small native village in Prince William Sound, lost 23 people, a third of its population. Today, scientists use ocean bottom sonar mapping to identify submarine landslide deposits from the past. Additional work, like coring and dating these slides, will help refine understanding of the tsunami hazard and how often these quakes occur.
And at Valdez in particular, it looks like there may be like 6 to 10 of these big underwater landslide deposits at depth. So we know that these kind of things happen over and over again. You know, here we are at the margin of a fjord, we've got these big mountains, there's glaciers and streams eroding these things, they're putting sediment at the margins of the fjord. We have the megathrust underneath us here at about 12 to 15 miles depth. In these big earthquakes, it shakes like crazy, releases these sediments into the deep parts of the fjord, and then generates tsunamis. So if you're living at the edge of a fjord or recreating and an earthquake happens, a really important thing to do is to travel to high ground right away. You don't want to wait to hear a tsunami alarm or anything like that. If you feel strong shaking that feels like a strong earthquake, you need to head uphill right away. Don't wait till the earthquake is over.
Some of the most stunning destruction from the 1964 quake came from subaerial landslides. Extreme shaking led to significant ground failure and liquefaction in Anchorage. Massive landslides struck the downtown area, Government Hill, and in the Turn Again by the Sea subdivision.
What happened is through the ground shaking in the 64 earthquake, there were these blocks that sort of slid sideways as a result of that. And then some buildings collapsed into those areas. Sometimes the edge of a building was sticking off where it had failed underneath there. There were a few people killed as a result of the damage of these buildings in the 64 earthquake.
The widespread damage and loss of life from this earthquake led to a determination to use science to save lives in the future. Legacies from the 1964 Great Alaska Earthquake include the establishment of the USGS Earthquake Hazards Program, NOAA's round-the-clock Tsunami Warning Centers, new building codes and innovations in retrofitting older, vulnerable structures. As part of the Advanced National Seismic System, the USGS now routinely monitors all earthquakes that occur in the U.S.
South Central Alaska here is the infrastructure center of the state, and it's also by far the largest population center of the state. And the work that we do It involves basically the fundamental characterizing of the earthquake hazard, knowing which faults are active, which faults can produce earthquakes, understanding how often those earthquakes occur. And another part is understanding the local tsunami hazard, getting an idea how often they occur, and doing tsunami modeling to understand where people would be hit by these tsunamis.